So today you're going to have two videos. One's going to be in modules under lab related, and the other is going to be on unit 1 at the bottom. Today we're going to start doing something called dimensional analysis or unit analysis. And what that is a very standard process for doing a word problem. So let's start off by looking at this simple algebra equation. A times C over A. What's the answer? C. Why? The A's cancel out, exactly. So instead of A's and C's, you're going to be using units like grams and liters rather than A's and C's. And the units have to cancel whenever you do a problem. They need to cancel to the answer's units. So you're starting with some unit, you're going to end with some unit. In between, everything's got to cancel out. And I'll give you lots of examples of that. Okay, every single problem has, let's see. Every single problem has 4 steps, period. No exceptions. Now, first step is balance a chemical equation. That's only if there's a reaction. If there's no reaction, there's no equation to balance. Now, unit 1, we have no chemical equations. Unit 2, that's all we have are chemical equations. In unit 1, there's no chemical equations. So for unit 1, we start at step 2. Okay, step 2 is what is given. And I'll show you tons of examples here. In fact, we're going to start with this one right down here. The third step is what are you trying to calculate? Now, these are numbers and units, not just numbers. For example, given is always a number plus a unit. What you're trying to calculate is only a unit. So when you're going through the setup, look for the number plus a unit. When you what are you trying to calculate? That's going to be a bare unit with no number. And then lastly is the setup. And the setup is a series conversion factors. So this is a game. You start with a given, how do you get to the end? And that's in every single word problem. So this is your strategy. A lot of teachers don't teach strategies because this relieves the anxiety of doing a word problem. What's step 1? What are they giving you? And what are you trying to calculate? And how do you get there? The first step, very straightforward. What information are they giving you? Now, it's important to understand that sometimes I'll give you extra information that's superfluous, not needed. That's kind of life. We live in a horrendously enriched data environment. And most of that data is not needed for everyday living. And we're getting into AI big time. Who in here uses ChatGPT? Anyone? I've got what? Last semester, half the class raised their hand. Half the class. So I encourage you to start fiddling around with ChatGPT. It's really cool. Also, kind of off the subject on ChatGPT, there is 2 ways to input a prompt. One is written, the other is voice. And if you use the advanced voice feature of ChatGPT, it'll actually understand your nuances. Like if you're excited about something, it'll note that. This prompt is with excitement. If you use the basic voice input, it converts it to text, and then you get the normal text prompt input. But if you use the advanced one, it's pretty cool. It's like chit-chatting with the robot head. And it really is like chatting with the robot head. Because it'll respond back to you in voice as well. So unless you tell it, I want a text output. Okay. So my point on all this is tons of data. Frequently, a lot of it is not needed, superfluous, etc. Now, I'm going to give you a take-home problem for test one. And the take-home problem is going to have a whole bunch of data, a whole bunch of givens. And you're going to have to go through and figure out what you want and what you don't want. But I'm going to give you like days to do it. In fact, I'll probably post it if I remember when I get home tonight or tomorrow. You'll have quite a bit of time to do it. Okay, so for unit one, we're looking at 3 steps. What's given, what we're trying to calculate, and the setup. Okay, so let's look at this problem here. Okay, so let's follow the steps now. What is given?
Question.
What are you trying to calculate?
The apples.
Right, so the given is number of apples. And put that on the left. Now, if you're comfortable in math and doing word problems, you may do this problem differently. Now, on a test, and I give you a problem, and you miss the answer, I'm going to look at your setup. If I can't understand your logic of your setup, I can give you partial credit. If you're one of those whiz-bang types that can do a lot of half the stuff in your head and it's not written down, I'm going to give you Zippo credit. I've got to understand your logic to give you partial credit. Okay? Just FYI, right out of the bag. I know some of you are very comfortable in math. Some of you hate math and are not comfortable at all. So what I'm trying to do is get this to be black and white. Okay, so number of apples is the given. What are we trying to calculate? Apples, right? Okay, so how do we go then? Now we're at setup time. Using conversion factors, how do we go from the given to the calculated? Conversion factors are all fractions, no exceptions. Okay, and we all know there are 12 in a dozen, right? Okay, so the first conversion factor is 12 apples, 1 dozen. Now, whenever you have a conversion factor, you also have the inverse of that conversion factor. So it always comes in twos. So we can go 12 over 1 or 1 over 12. Those are both the conversion factors for apples in a dozen. Okay, you all see why we have 2 conversion factors. Now the question is, which conversion factor do we use here? Okay, so we have the 2 conversion factors we're going to use with this problem. Which one do we use? And you're saying, oh my God, it's a word problem. Let me show you a way you don't have to even think about it. Units have got to cancel. So if we apply the first one, apples cancel. What does it leave us with? Doesn't. If we use the second one here, apples does not cancel. So that means that one we're not using. So we're using this one here. So let's rewrite this. We have 34 apples times dozen over 12 apples equals dozen. Now, always cancel out the given. No exceptions. So that's why this one here is not valid, because it doesn't cancel out the given. Here, the given cancels. If the given cancels, we know it's a good step one. If it doesn't cancel, get another conversion factor. So we've got 34 times 1 divided by 12. Now, for all of you that are new to math or hate math, you may put the 1 in your calculator. My A students last semester started off as a babe in the woods regarding math. She hated it. High school, middle school, hated math. She got an A in my class. Not just an A, a 98% A. Really solid student. But she was really detail oriented, and she would go in her calculator, 34 times 1 divided by 12. And I was telling her, I said, you don't need to put the 1 in. She said, she says, I can do it if I put the 1 in. Put the 1 in. Okay. So we're at okay. So this is a division problem or a multiplicative inverse multiplication problem. So we're going to be using the rules for multiplication division. So how many sig figs is 34? 2. What about for 1 dozen 12? Infinite. By definition, infinite. So which is smaller, 2 or infinite? 2. So our answer is going to have 2 sig figs. Now this is what my calculator gives me. And actually underneath the covers of this calculator, it goes out to 29 places. Depends on your brand of calculator and how much you pay for it. Some go out to 12, others go more. Okay, so we need to convert this to 2 sig figs. You go to the third place. And that becomes, it's 0 to 4, so we just drop it. So it becomes 2.8 dozen. I write 2 sig figs in all my answers only for illustration for you guys. You guys can write 2 sig figs if you want, or just leave it as 2.8 dozen. Now, if I was grading this problem on a test, say the problem is worth 10 points, you get 9 points for that, 1 point for that. Yeah, I was telling you yesterday. Yeah.
For the test, we want 100 and convert it to the two days of birthday. The whole number, 2.3333 doesn't then convert it to.
Yeah, that's what my calculator gave me. No, yeah, you can do the 2.8, that's fine. Yeah, a lot of people put the whole number in anyway. So. Huh?
Is it okay if we do?
Oh, for sure, yeah. Yeah, that's being real anal if, no, you can't put that down. The fact that you put the whole number down and you make an error converting to 2 sig figs, I'll give you credit for that. So, okay, my job is to make you successful. My job is not to see how many students I can flunk. There are professors that pride themselves and their class goes down by 60 to 80%. One student told me she took a class, not saying which professor, and they ended up at 8 students end of the semester. I would look in the mirror and say, something's wrong with my teaching if I lost that many students. Seriously, I pride myself in helping as many students as possible. I give you many modalities of learning so that you can be successful. Okay, that's why I don't do multiple choice tests. My late wife would always say, "Why aren't you doing multiple?" Because I always complain about how many tests I got to grade, and she says, "Don't complain." She says, "Just give multiple choice tests." I said, "But my students don't do as well. They do better with my version of fill-in questions because I can give them partial credit. Multiple choice or right or wrong, nothing in between. Even if you make a silly little calculator error, your setup is worth 90%. Multiple choice, it only goes by the answer. Now, I work for a company that used to write statewide tests. And I was the math consultant they used. And so I wrote a zillion multiple choice questions for statewide testing for various states. So what you have to do, you have to analyze the problem and you have to think through all the common mistakes students make. And those are the answers, the common mistakes. And then there's the real answer buried in there. So if you're doing the problem wrong, you'll see your answer as a possibility. Okay, so that's why I give the test the way I do. I'm going to give you an example test on Monday. You'll see, and why I give practice tests, they're old tests. That's another thing. I give you the old tests so that you can know how long the tests are going to be, how I set up the questions, all that stuff. So everyone says, why don't you collect the tests back? And then you just give them out the next semester. Yeah, so I have a whole bunch of practice tests from old semesters that you can see. Most of the time I have keys, sometimes I don't have a key. So someone had a question over here. Is it? Yeah. Say again, louder.
Where is the 12 and the fraction for the 12 animals and 6 pigs and the 34? So,
Over here.
yeah,
Now what's canceling are the units, not the number. Is that your question?
No, he's asking about the significant figures, why the dozen is infinite.
Okay. 34 is 2 sig figs. This is by definition, so it's infinite. So you always go by the answer in the linear multiplication problems by the smaller of the 2 sig figs. The 34 is smaller than infinite. So our answer is 2 sig figs.
but why is the 12 apples? What would it consider?
Because it's by definition, it's not measured.
Oh, it's just the value and the number one, not that. You're saying it's the unit.
Yeah, so if I give you a definition, like there's 2.54 centimeters in 1 inch. By definition, so that means 2.54 is not 3 sig figs, it's infinite. And in the sheet I'm going to pass out today in lab or tomorrow in lecture, I'm going to have everything boldface. That's by definition. Like all the metric stuff is by definition. So they're all infinite. Like 1,000 meters in a kilometer. By definition. So those numbers are all right, because the one is 1 sig fig, right? Yeah. Okay, so that makes sense? Okay, cool. All right. So are there any questions about this technique? Now you're going to be using this technique from now to the end of the semester. Unit 2 is, we're actually getting into the math part of chemistry, big time. This technique. We get into unit 3, we're using solutions, solution chemistry, math, big time. And we're using this technique the whole time, yeah.
So Or are we unit, 2 units for 1 week for this class?
No, there are 4 units and
4 units, 8 weeks.
so it's 2 weeks in unit approximately.
So for like, if we're wanting to like read the textbook that was given, how many chapters would you say are within that 1 unit?
Look at the lecture lab schedule. I'll tell you what chapter per day.
Okay.
You just kind of, because it varies. The most important units, by the way, are 2 and 3. Those units will help you the most in your next chemistry class. Unit 4 is what's left over after I covered unit 2 and 3. And unit 1 is to get you practiced on doing a problem, how to set up a problem correctly. So pull up the file on the lab schedule, lab lecture schedule. And I have every day identified, and that's also subject to change. Depends on how things are going. Okay, so let's do another problem. 30, no more questions, right? Okay. Now this is, by the way, a 1-step problem. 1-step meaning it has 1 conversion factor. This will be the simplest type of problem by far. Before I go on, there are 3 types of problems we're going to encounter. And you're going to encounter all 3 of these on lab 2, or lab 2. One is a simple given. Example, grams to kilograms. Would be a simple one, okay? So we start with something like grams or whatever, and then we end with something similar. Number 2, if we start with a fraction, you end with a fraction. So if the given is a fraction, your answer is going to be a fraction. And then we're going to do something in the linear measurements called linear square cubic. So if you start with something that's linear, like 2 inches versus 2 square inches versus 2 cubic inches. So if you start linear, you're going to end in linear. If you start square, you're going to end square. I'm going to do examples of all these. If you start cubic, you're going to end cubic. So on dry lab 2, you're going to be doing all these, mostly this type. But you're going to be given a fair amount of data. Now the problems in dry lab 2, there's going to be no insignificant data. You're going to use all the data given, all the conversion factors, all that stuff. Okay, so these are the 3 type problems anyway. And this pretty much covers unit 2 and unit 3 as well. Okay. Now, when you're reading the problem, if you see the word per, that's a conversion factor. For example, I eat 3 apples per day. Per, immediately conversion factor. And what is that? That is 3 apples per day, or 1 day per 3 apples. Now, in dry lab 2, you're going to see a lot of this, a lot of pers. And as soon as you see that red flag, boom, conversion factor. Okay, so let's look at another one here. How many inches are in 34 centimeters? Okay, what's given? 34 centimeters. What are you trying to calculate? inches. Okay, so this is the conversion table that I modified from Dry Lab 2. Now, the way I modified it is all the stuff that has infinite sig figs. I'm going to give you a copy of this, a copy of this. Is in bold. Now, the one in your lab is italicized. And it's really hard to tell the italicized from non. So I said, screw that, make it bold, so it's really obvious what is defined. So everything bold is by definition. So by definition, there's 2.54 centimeters per inch, 16 ounces to a pound, that kind of stuff. Also, I enlarged the metric table. Metric to metric conversions are very common in the sciences. In fact, it's very interesting. There was a jet crash, 737 in Canada. And Canada uses liters, not gallons. When they fill the plane up, they saw, 450, whatever, and they put in 450 liters. Well, the plane meant gallons. And a liter is a little more than a quart. So the plane ran out of gas. One of the lunar landings, this is NASA now, made a mistake. Also, inches versus centimeters. And one of the rovers is all screwed up. So things happen, but just be really careful. Units matter. I mean, a t-shirt. Units matter. Okay, so anyway, I redid this. So again, I'm gonna copy this for everyone. In fact, I'm gonna do it during lab today. So if you want to follow me over to 104, I'll then put this on a flash drive and go to the copier, make copies of it. Or you can just wait till tomorrow. Either way. Okay, so what conversion factor do I need to do this problem? Well, I need a conversion factor that has centimeters and inches in it. The next question is, you might be asking is, well, if you don't find one with centimeters and inches, well, is there one of them with centimeters in it and another with inches in it? And I can convert between the two. And that's the most common situation. But for these early problems, you're going to find conversion factors that have both centimeters and inches in it. Okay, if you look over here, there's one there. Now you ask yourself, that's not a fraction. Well, we need to make it into a fraction because whenever you have a conversion factor, what is that equal to? 1. The reason why it's 1 is because those two are equal. It can only happen if they're equal, the numerator and denominator. So we have the conversion factor over here. We have 2 of them. We have remember, 1 inch is equal to 2.54 centimeters. So those are equal. That's why we can flip them to the inverse. So which one of these are we going to use? What has to cancel? Always. The centimeters. It's a given. So that means centimeters needs to be on the bottom to cancel. If on the top, it won't cancel. So that means we're going to use this guy here. That one, given, won't cancel. Okay, how many sig figs is 34? And this is by definition, so this is infinite. And our answer is going to be 2 sig figs. Okay, so we go to the third place. And that's 0 to 4, so we drop it. So the answer is 13 inches. Okay. So how many miles are in 12 inches? So what's given?
Well,
Trying to calculate. Okay, so we go over here to conversions. So we need inches per mile. Right? Do we see a conversion factor inches to miles? No. So now this is going to be a more than one step problem. So do you see something with miles in it? With this. And what about now? We have inches and miles and 2 conversion factors. And what's the common unit between those conversion factors? Feet. So we're going to convert to feet first, then inches. So whatever's common, convert to that first. Now you're going to see in unit 2, there's something called moles in chemistry. That's the common unit in almost everything. So if in doubt, convert to common unit. If in doubt. So we're going to go. So what's our first step? Inches to feet or feet to miles? Let's get into feet because that's the common between the two. Inches, I've got to cancel because it's a given. And now we have, once the inches cancel, we have feet. Now we need to go from feet to miles. Go back over here to our table. Bless you. And we have 5280 feet per mile. Feet cancels. And what are we left with? Miles. What are we trying to calculate? Miles. So this is a good example of a two-step problem. Now, I want you to think of the fraction bar as continuing all the way across here. You have one giant fraction. We have some things on the top, things on the bottom. Things on the top are being multiplied, things on the bottom are being divided. And that means every time there's something on the bottom, you hit the divide key, even though these are being multiplied 12 times 5280. As far as a calculator is concerned, the dumb calculator, it's a division problem. Okay, so we're going to multiply everything on the top, hitting the times key, and then we're going to hit the divide key for everything on the bottom. So we're gonna go 12 times 1 times 1 times 1 is 1. I mean, it's 12. Divided by 12, hit the divide key again, 5280. So we're looking at okay, 2 sig figs, infinite by definition, so our answer is going to be 2 sig figs. Okay, so we go to the third place. That's 5 to 9, so we're going to kick up the 8 to a 9, so it's 1.9 times 10 to the 4th miles. And when I do these problems, it'd be good if you at your seats do them and make sure you get the same answer as I do. And sometimes I make mistakes. It's called, I'm human, I'm old, so I make mistakes. And I have no problem with you guys saying, that isn't what I got blah, 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 and we'll work it again, okay? I have no problem with you saying that, because I want to make sure everything we do is accurate, yeah.
Work again. How you came to the conclusion of 1.89.
Okay, so you go 2 sig figs.
Yeah, so if we're like canceling out all of our unit.
Yeah.
So then you're left with basically 1 over the 63,000.
Left with 1 mile.
Correct, 1 mile over the amount of 5280 times 12. So then 1 over 63,360 if you multiply those two.
Right.
So then how did you get 1.89 on that?
Because I multiplied 12 times 1 times 1, divide the whole thing by 12, and divide the whole thing again by 5280. Now you can do it in 2 steps if you want. Some students don't like to do one calculation. They'll multiply everything on the top, everything on the bottom, and then do another calculation. It sounds like that's what you did.
Yeah, because I got to the point where it's still a fraction. And I guess that's where I'm like,
And then you divide the bottom number by into the top number on your fraction.
but then in that case, oh, I see. I see. I'm leaving out our given, which is 12. This is what I got. I didn't multiply it by the given, so I'm getting 1 mile. Right? So this will actually be 12.
Yeah.
Got it.
And what do you divide? That's equal by that.
I think I was like, so,
Better?
yeah, I was like, I don't know how you got that.
Exactly what I want you to do. Verify what you're doing. And if it doesn't agree, you do.
Thank you.
Sure. All right, there we go. Okay. Now this is a really good example of a multi-step problem. Okay, this is the last thing we're going to do today. Okay. I want to make sure everyone is okay with this multi-step. Now, sometimes there are like 5 steps. Lab 2 has got some simple problems and it's got some big problems. So tomorrow we're going to, continue to work on different kinds of problems, multi-step, how to work well. And then could someone send me an email and remind me to post the take-home problem? Did you do that? All right, so any questions at all about this, what we've done? Okay.